Namaskar my dear students. Today we are going to learn about the cumulative fatigue damage or Wiener's rule with one example. Let us take example. The work cycle of a mechanical component subjected to completely reverse bending stress consists of the following three elements. Plus minus 350 Newton per mm square for 85% of time, plus minus 400 Newton per mm square for 12% of time, plus minus 500 Newton per mm square for 3% of time. The material for the component is 50C4, in which ultimate stress is 660 Newton per mm square, and the corrected endurance limit of the component is 280 Newton per mm square. Determine the life of the component. Now you have already studied in theory portion Wiener's rule. So what is the equation of the Wiener's rule? So equation of the Wiener's rule is alpha 1 upon n1 plus alpha 2 upon n2 plus alpha x upon nx is equal to 1 by n, and alpha 1 plus alpha 2 plus alpha 3 plus alpha x is equal to 1, in which this n is life of the component that we have to find. Okay. Now let us solve this example. So this example is solved by three different steps. Okay. In which first the given data, and the given data are ultimate stress is 660 Newton per mm square, endurance limit is 280 Newton per mm square, alpha 1 means the time period for the first cycle is 0.85, alpha 2 is the 0.12, and alpha 3 is 0.03. Stress cycle, first sigma 1 350 Newton per mm square, sigma 2 400 Newton per mm square, sigma 3 500 Newton per mm square. Now first step, construction of ascent diagram. So in which let us find the different values to construct the ascent diagram. In which first we have to find the 0.9 SUT, value of SUT is 660, so 0.9 SUT is equal to 594 Newton per mm square. Now find the log 0.9 SUT. So log 0.9 SUT is equal to 2.7738. Now find the log SE. So log SE is equal to 2.4472. Then next is log sigma 1 is equal to 2.5441. Log sigma 2 is equal to 2.6021, and log sigma 3 is equal to 2.6990. Now with the help of all this data, construct the ascent diagram. You can see here in this ascent diagram, on the x-axis log n, on this axis log SF. Okay. Now this ascent diagram, it starts from this point A, where it is value is log 0.9 SUT. So 0.9 SUT 2.7738. At this point B, it is the endurance limit. So log SE is equal to 2.4472. Okay. Now at this point E, it is value of log sigma, and you have to find the corresponding value of at point F is log n. Okay. Now you can see here two similar triangle AEF and ADB. Okay. So from these two similar triangle, in step 2 we have to find the value of n1, n2 and n3 from the ascent diagram. So from these two similar triangle, EF is equal to DB into AE upon AD. Now put the value dB is 6 minus 3, A is equal to 2.7738 minus at point E is log sigma, and AD 2.7738 minus 2.4472. Okay. Now we know that log n is equal to 3 plus EF. Okay. So now in this equation put the value of EF by simplifying this. So the value is log n is equal to 3 plus EF, value of EF. By simplifying this equation you will get the 9.1855 into bracket 2.7738 minus log sigma. Now using this equation we have to find the value of n1 by putting the value of sigma 1, value of n2 by putting the value of sigma 2, and value of n3 by putting the value of sigma 3. Now let us find one by one. So log n1, so 3 plus 9.1855 and value of log sigma 1 is equal to 2.5441. So here n1 is equal to 1,28,798 cycle. Similarly, find the value of n2 by putting the value of sigma 2 in this equation. So n2 is equal to 37,770 cycle. Similarly, you can find the value of n3. So n3 is equal to 4,865 cycle. Okay. Now step 3 is find out the fatigue life of the component. That means we have to find the value of n with the help of Miner's rule. So alpha 1 upon n1 plus alpha 2 upon n2 plus alpha 3 upon n3 is equal to 1 by n. Now put the value of n1, n2, n3 and alpha 1, alpha 2, alpha 3 in this equation. So 0.85 upon 1,28,798 plus alpha 2 is 0.12, n2 is 37,770 plus alpha 3 is 0.03 and n3 is 4,865. Now our answer n is equal to 62,723 cycle. So life of the component is 62,723 cycle. Thank you.